Today we're going to take a look at graphing inequalities on the number line. And the reason why we do this is because inequalities have an infinite number of solutions, which means there's no possible way we can write them all down. So instead of writing them all down, we're just going to represent all of those numbers on a number line. So there's a few things that we need to know about a number line to start with. Okay, when we're graphing an inequality on a number line, we want to give ourselves sort of three numbers on our number line, where the number that goes in the middle is always going to be the number we see as the answer, as part of the answer. And then we always want one number to the right and one number to the left. Students typically are fine doing this with positive numbers, but as soon as it gets into negative numbers, sometimes my students are a little bit confused on what numbers to put where. So remember, negatives on the number line kind of look backwards, right? So over here to the right, we would have -5, and to the left, we would have -7. If you're not certain on what order your number line goes in, okay, you can always know that the number to the right is always one larger. So in your calculator, you could do -6 plus 1, which would give you -5. And the number to the left is always one smaller. So in your calculator, you could do -6 minus 1, which would give you -7. We also need to understand a couple rules about inequalities. The first thing that would be great is that we know all of our symbols. Okay, so when this is opening to the left, okay, we say that this is an is greater than. Okay, when it's opening up towards the right, this is going to be is less than. And then we also have symbols that open those same directions, but they have a line underneath it. Okay, and that's just going to add an or equal to at the end. Okay, so when it opens this direction, this is going to be is greater than or equal to. And the same thing underneath. Okay, this is opening the same direction, so it still is less than. But it's going to be is less than, and now we have the line, so or equal to. Okay, if we have something that says x is greater than 2, this actually means that x can't be the value 2, but it can be any number that's greater than it. So 3, 4, 10, 100. Okay, it could also be 2.1, 2.00005. Okay, anything that is larger than 2. Okay, whereas x being greater than or equal to 2 says not only can it be all of those numbers that are larger than 2, but it can also include 2 as well. So this minor difference in the inequality look of the sign actually gives us an included number that we didn't have before. Which means when we graph on the number line, we're going to have to graph them slightly different. Okay, so what we're going to do is if we graph and we have it a greater than or less than symbol, we're going to use an open circle on our number line. Okay, that open circle is going to mean that this is the place that we start, but we can't actually include the number that it's at. Whereas if we have greater than or equal to or less than or equal to, this is going to be a filled in circle. And the reason why it's going to be a solid circle is because we want to include that the point that it's at. It counts. That point is included in the solution. Okay, we're also going to have some shading rules. So if we have greater than or is greater than or equal to, we are going to shade to the right. Okay, we will shade right because that will say any number that is to the right is larger than or is greater than. Okay, with less than or equal to, we are going to shade left, right? Any numbers to the left on a number line are less than. So some rules for helping you remember are maybe that a solid line underneath means you're going to graph it with a solid circle. Okay, less than means to shade left. The key here is that none of these rules work unless the variable is first, which means if we want to graph something like 6 is greater than or equal to x, we can't graph it using the rules I just gave you because the variable isn't first. So in order to get the variable first, we need to swap places, okay, with the variable and the number. But once we make that swap, we're also going to have to change the direction of the inequality sign. Okay, this is then in the correct format, and we can now graph this. So if we make a number line, okay, just like we said above, we want 3 points on our number line. So we want the number that we're given, the 6, to be right in the middle. Okay, then we're going to decide, if we look at our list, this inequality symbol, less than or equal to, right, told us that we want a filled in circle or a solid circle at 6. Okay, then this is less than, so less than's fall down here for shading. Less than or equal to says shade left. Okay, if we have our other numbers on our line, 1 to the right, 1 to the left, right, 5 is less than 6. That's why we're shading this direction. All the numbers that are less than 6 on the number line are all included as potential answers. Now, when we're graphing, sometimes our numbers can get a little bit weird, which means we might also have things like graphing x is greater than 5 over 2. Okay, so if we want to graph this, we need to know a little bit more about getting things on the number line. Oftentimes when students have an improper fraction, they would prefer for this to be graphed as a mixed number or as a decimal. So you can either by hand or with your calculator divide this out and realize that 5 over 2 is really the same thing as 2.5 or 2 1/2. Okay, anything that's not an integer number, which means no decimals or fractions, right, we're going to sort of approximate on our number line. So we can still just put 2, 3, and 1, right, because this is going to include the 2.5. We're just going to approximate that it's in between, halfway in between 2 and 3. Okay, so we will put an open circle at 2 1/2. And because this is greater than, we will shade to the right. Okay, if we maybe even get into some more complex numbers, right, the letter doesn't matter. Maybe we have this y is less than the square root of 5. If we want to be able to graph something like y is less than the square root of 5, we need to be able to approximate this answer. Unfortunately, approximating this answer would be a problem we would be asked to do without a calculator. So we would need to be able to decide, what do we know about square roots? Well, we do know that the square root of 4 equals 2. We don't know the square root of 5. We don't know the square root of 6, the square root of 7, the square root of 8, but we do know that the square root of 9 is 3, which means all of these values have to fall in between 2 and 3. And since 5 is really close to the square root of 4, we should assume that it's just a little bit larger than 2, which means if I put this on my number line, okay, again, I'm going to have to approximate, but I know I'm going to be just a little bit larger than 2. So this symbol is telling me to use an open circle, and less than is telling me to shade to the left. So I want you to try the 10 problems on the worksheet on your own, and then watch the next video to check and make sure your answers were correct.